Hi my friend, it's Joey from Joey's Tech, and in this video of Joey's Tech we are going to solve one of my most favorite problems of all time, the box stacking problem. Now with the term box stacking problem, you must have assumed by now what actually it is related to, and it's going to be too much fun solving this problem because you are about to add one of the coolest problems to the learning corners of your mind. Okay, now if you haven't subscribed to my channel till yet, then please do so because that encourages me to make more such videos on some of the best computing problems of all time. And do not forget to hit the bell icon because that way you will get notified whenever I release any new video of Joey's Tech. Now let's begin analyzing the problem. So here are our boxes. Obviously box stacking problem, that means boxes have to be there. So you are given two boxes of dimensions 4, 6, 7 and 1, 2, 3. The thing is that you need to form a stack of boxes such that every box on the top is strictly smaller than the box beneath it. So you are going to form a pyramid of the boxes or the boxes stack. You can assume you must have seen it several times in your life, such that every box on the top is strictly smaller in base area than the box beneath it. All right. Now the boxes are in unlimited supply. That is one of the conditions of this problem. So obviously you can rotate all these two boxes, and since they are in unlimited supply, so you will have 6 boxes in total because 3 rotations are possible per box. Okay, so you will have in all 6 boxes available, and you need to choose those boxes with which you can form a box stack such that each box is strictly smaller than the box beneath it. But there is a crux to this problem, the gist to the problem. Okay, there is something which is sitting on top of the problem which I'm going to reveal next, and which is the most important condition of this box stacking problem. It is that the box stack has to be of the maximum height possible. Okay, so the height of the box stack has to be maximum. Now, the box stacking problem has longest increasing subsequence algorithm in its foundation. So I have created a video already on longest increasing subsequence using dynamic programming. You can watch that if you haven't, and then come back and watch this video, or you can keep watching it and watch it later. It will help you understand this better. Okay. Now you are going to ask me, Joey, how do we know that we need to use LIS algorithm here? So the answer to that is, in LIS we find the maximum set of integers which are in increasing order. So we are given a set of integers and we need to find those integers which are in sorted order, that means from lowest to highest, and the subsequence has to be as long as possible. So there we concentrate on finding the length has to be the highest. All right, now if you draw an analogy between the integers and heights of these boxes, okay, you need to choose those heights or those boxes, the combination of which forms the maximum height instead of the length of the integers, like we do it in longest increasing subsequence. So we focus on maximum height. In LIS we focus on the highest length, but here we have to choose those boxes. Okay, like there we choose the set of integers, okay, which give us the longest length or the highest length, but here we need to choose those boxes from which we get the maximum height. So that way these two problems are interrelated. It is similar, but they are interrelated. This box stacking problem is similar to LIS, but it's not same as LIS. Okay, you have to keep that in mind. So now let's move to our framework where we will solve the box stacking problem. All right, so here is our framework. These are our two boxes. I have written the dimensions here. Okay, so 4, 6, 1 was our first box, and 1, 2, 3 is our second box. Here, this box stacking problem, okay, just runs on one assumption that is going to make solving this problem easier. Now that assumption is that the breadth has to be less than the length always. Okay, that way we generalize the problem, and on this assumption we can solve it in a much easier way. Okay, now I have listed down here all the rotations of these boxes. Okay, so since we are assuming that the breadth is always going to be lesser than the length, hence we are not going to consider that rotation where the breadth is going to be greater than the length, and that is why we are focusing on only 3 rotations. All right, so we have also calculated the areas of different boxes because we will be going by the base area. All right, because if we are planning to put a box on top of a box which is strictly smaller, then obviously base area will come into picture. All right, so 24 is the base area of this particular box, 28 of this, 42 of the third box, 2 of this box, fourth box, sixth of fifth box, and third of the last box. Now what we need to do, we will sort these boxes in descending order of their base areas. Why we are doing that? Because the box with the greatest base area is going to come at the bottom, so sorting them in descending order is going to help us, because that way we are going to describe a hierarchy already, and that will help facilitate our longest increasing subsequence algorithm. All right, so let's sort the areas over here. So 42 and I am going to write the dimensions over here, 7, 6, 4. Here 28, 7, 4, 6, 24, 6, 4, 7, then 6, 3, 2, 1, then 3, 3, 1, 2, 2, 2, 1, 3. So for sake of clarity, I'm going to hide these 3 columns. Okay, they are hidden, and I have numbered these boxes. Now, thing which I was trying to say is that why we have sorted them in descending order is that this box cannot be on top of this box because it is going to be at the bottom only. Okay, so this hierarchical order is going to facilitate our problem solving. We are not sure whether this box is going to be on top of this box because that depends on our LIS algorithm. So this is how this descending order thing is going to facilitate our LIS algorithm. Now we have 2 arrays over here. This array we will use to find the maximum height. Okay, and this array will be used to find the components of the box stack. That means the boxes which will be used, okay, from these. Fine, so I am going to fill this array with the respective heights of the boxes, because we focus on the base state while solving longest increasing subsequence, then we fill this array with 1, because at any point of time or at any cell or at any set or at any integer in the set of integers, if we just take that particular integer out and we say, okay, what is the length of the longest increasing subsequence, it is always going to come out as 1, because there will be only one integer. Similarly, if I just pick this box out and I tell you that there is only one box, just tell me the maximum height. So the maximum height is obviously going to be the height of that box, because we won't have any other boxes to compare. All right, that is why the base state will contain the heights. Okay, this has been explained properly in the video which I have made on longest increasing subsequence. Okay, so now let's proceed. So we'll have I counter over here and J counter over here. Okay, so we will compare on one basis that the box in consideration, okay, is strictly less than the box, okay, which is going to be beneath it. Okay, so that is going to be our condition. So here we have here we have the J counter on box 0 and I counter on box 1. Now let's compare these two. So if you compare the length and the breadth, don't go for the height because height won't be of any value when we are comparing the base area. So is this box strictly lesser than this box? No, because we have the same length over here. That is why, okay, nothing will happen over here. Fine. The I is going to move one cell to the right. All right. Now, so we have I on this box and J on this box. So let's compare these two lengths and breadths and find out if this box is strictly smaller than this box. So is this box strictly smaller than this box? Yes, it is, because here we have length and breadth as 7, 6, but here we have it as 6, 4. So what we are going to do, we are going to add this height to this height and we are going to get the value as 11. We will compare 11 with this value and we are going to find out if 11 is greater than the value already present over here. So the value already present over here is 7. 11 is greater than 7. So we are going to replace this value with 11 and I am going to put 0 over here. Okay. Now one more thing, I will fill this with their respective values. Okay. This is the boxes finder. Fine, we already do it in LIS, so it will be clear when you're going to watch my LIS video. But why I have put 0 over here, because just to notify that box number 2 is on top of box number 0. Okay, so why we did that? We are just combining the heights. Okay, and this is a sub problem, so we are just storing the optimized result over here, which is the crux of dynamic programming. All right, now I moves one cell to the right. Okay, now let's compare this box with this box. Is this box strictly lesser than this box? Yes, it is. Okay, so I am going to add 4 with this value, so it is going to give me 5, and since 5 is greater than 1, I am going to put 5 over here and this value will be 0 because it means that 3 can come on top of 0. Okay, now J moves one cell to the right. Now, is this box strictly lesser than this box? Yes, it is. It is. So what I am going to do, I am going to add this 6 to this one over here. Okay, not to this value because this is the optimized result of our previous sub problem. So 6 added to 1 is going to give me 7. 7 is greater than 5. Yes, it is. So I put 7 over here and I place 1 over here, because just to make sure, just to notify that 3 is on top of box number 1. Okay, now J moves one cell to the right. Now, is this box strictly greater than this box? Yes, it is. So what I'm going to do, I'm going to add this 11, not this 7, this 11, because this is the optimized solution I have over here. Okay, because that also represents that we already have 2 boxes here. Okay, so 11 will be added to 1, so I'll get 12. 12 is greater than 7, so I'll keep 12 over here. I will replace this one with 2 and that's it. I moves one cell to the right and J goes to its base position. All right, we are doing good. Now consider this box and this box. Is this box strictly lesser than this box? Obviously it is strictly smaller. So this 4 will be added to this 2, or you can add to this 2 as well. So it is going to give me 6. Now 6 is greater than 2, so I'm going to put 6 over here and 0 over here. Good. Now J moves one cell to the right. Now, is this box strictly smaller than this box? Yes, it is. So 6 will be added to this 2. So we are going to get 8. 8 is greater than 6. So I'm going to replace this 6 with 8. And the value which I'm going to store over here is 1. Okay. Now J again moves one cell to the right. Alright, so this box over here, alright, box number 4, is it less than box number 2? Strictly smaller than box number 2? Yes, it is. So we are going to add 11 to this 2. I'm going to get 13. Okay, 13 is greater than 8, so I'll store 13 over here. Okay, and 2 over here. We are doing just fine. So J moves one cell to the right. Now, this box, is this box less than, strictly smaller than this box? No, because we have the same lengths over here. Okay, so this particular step will not be considered. This particular iteration will not be considered. J will go back to its base state and I will move one step to the right. All right, now we are at our last box. Now compare this 5 with this box 0. Is it strictly smaller? Yes, it is. So 4 plus this 3 or this 3 is going to give me 7. 7 is greater than 3. So I'm going to replace this value with 7 and I will place 0 over here. J moves one cell to the right. All right. So this box strictly less than this box, smaller than this box? Yes, it is. Okay. So 6 will be added to this 3. I'll get 9. 9 is greater than 7. So I'll place 9 over here and 1 over here. J moves one cell to the right. Now box 5 with box 2. Is it strictly smaller? Yes, it is strictly smaller. So 11 plus 3 is going to give me 14. 14 is greater than 9. So I will put 14 over here and 2 over here. Cool. Now J moves one cell to the right. Now is 2 1 greater than 3 2? Yes, it is. It is. So 2 1 is greater than 3 2. So this 12 will be added to this 3. Okay. So I'll get 15 as the value. 15 is greater than 14. So I'll place 15 over here and 3 over here. All right. So this gives me 15 and this value becomes 3. Now J moves one cell to the right again. Now is this box strictly smaller than this box? No, because we have ones as same. Okay, so this iteration will not be considered. All right, so our loop has run, our algorithm has run its course, and we are going to traverse through this array and we will spot the maximum value. Here I can see that the maximum value is 15. So 15 becomes the height of our box stack, the maximum height of our box stack. Now let's find the components, the component boxes of our box stack. Okay, so what I'm going to do at 5, okay, so 15 is at 5. So my first box is going to be 2 1 3. That means, okay, what I'll do, I will mark it over here. That way it will be more clear to you. Okay, so 2 1 3 is going to be my first box. Okay, then the value over here is 3. That means 5 is on top of box number 3. Okay, so I go to 3 over here and I mark this as my second component. Now on 3 I have the value 2. That means box number 3 is on box number 2. All right, so I go to 2, but I just mark this box as my third component. and on 2 I have box number 0. Okay, so I go to box 0 and this becomes my last component because we have already reached 0. Okay, so this way we have found out the boxes which are going to form the stack. Okay, and the maximum height of these boxes is going to be 15. We are going to check it again because it is too much fun. Okay, so 4 plus 7, I'm sorry, 4 plus 7 is going to be 11, plus 1 is going to be 12, and 3, 15, and that is our answer. And this is the solution of the box stacking problem. So with this, we have come to the end of this video. I hope you enjoyed watching this video. I'll see you in the next video of Joey's Tech. And if you have liked this video, just hit the like button and share it as much as possible. Goodbye.